Okay, hello, good evening, guys. We will be starting off with the session, and today's agenda and today's motto is to cover data structures and probably some of the algorithms. In our data structures, most of you know, as it includes linked lists, trees, then after graphs, arrays, all those structure. We will be covering up arrays, linked list today itself, and I will be explaining the coding aspect and the technological part behind that one. So I'm taking 5 minutes. I'm giving you 5 minutes of time. People will be gonna joining over on this. Video chat. Probably this live session, and we will be starting this one off. So we will be starting at 6:10. Okay, guys, so we can start off with our session. As mentioned earlier before, our major motto and agenda is to cover what? Data structure and algorithms. Fine. In this topic, arrays are a major part dealing with the concepts. I know most of you are aware with this what are arrays, and people who are not aware, it will be a best session for you guys, and people who are aware, it will be a quick revision and recapitulation for you as well. So arrays, everyone know it is what? It is a set of collection of a data. Like what is the useful of our array? What is the benefit of our using array? Consider that we have a variable what a, and I can store a value like a equals to 5 or a equals to 10. Fine. And I can store anything like string a equals to I can dance, I love to dance, anything like that one. But if someone says to be as what? I want to store a lot number of variable, I mean values over in a single variable like e equals to 5, then 10, then 10,000, 10 lakhs. I want to store a lot number of my values over on my array on a single variable, sorry. So then it's beneficial for using my array. So array is what? With the help of my single variable, I can use as in like I can store a lot number of values. And I forgot to mention that, guys, as it is not a one-on-one session, as it is a live session, what you are do is that if you are having doubts, you can type it over on the live comment section. I can see over on that those parts. Then I will be explaining your doubts as well. So probably we have finished up what is the definition of an array is all about and why it is necessary over on that sense. So I think arrays definition is done. Before that, as it was also mentioned that arrays are two types. One is called single dimensional array, one is called double dimensional array. Now, what is the use of it? Single dimensional array is used for what? Storing a single kind of a variable. Like if I am storing numbers, so I can store 5, 10,000, anything if I want to. Then after, if you want to store a matrices kind of a thing, so most of you have done matrices over on your lower grades in mathematics, right? So if someone wants to store a matrices kind of a thing value, he or she shall be requiring what? A double dimensional array. That is what a DD array. Now everyone has understood that is what is the single dimensional array and what is double dimensional array. I think I'm clear with that one. Next, what do we have is that consider that we want to store array. How we will be storing array? For that, of course, we will be requiring loops. Why loops? Until and unless we will be requiring looping structure, we won't be able to store our array elements. That was its most important aspect. For storing the array elements, we will be requiring a looping structure. When we are done with this one, guys, you lately when the link, I mean when I will be ending up the session, you can pause the video and you can just check out this one. What is the definitional aspect is being written over there? I'm not reading and going on to it, but I'm just going with the explanatory purpose of that one and the important concept. So if I just go with everything, we will be losing time. So that's why it is not required as of now. Then after, a dimensional array is what? It's a structure created in the memory to represent a large number of same types of a data. That is either I'm storing string type of value. Yeah, I will be storing only string type of value like names or anything like that. If I'm storing integer type of a value, of course I will be storing like a numbers type of value. I won't be interchanging with any other concepts. So if I'm storing string again, I'm back again, I'm storing strings, it won't be possible. So a data source set should be like a similar kind of a value. Now with the help of a single variable. So single variable like I can store it any variable like A, B, C, anything like that one. So I think I'm clear with the definitional concept. Then after it says to be as what? A dimensional array is basically of two types. One is to be called a single dimensional array, double dimensional array, which I've told you. Then it is what it is represented by rows. And now this is one of the important concepts. When I've told you it is a part or example of matrices, that means it is what it contains rows and columns, right? Getting the point? So when rows and columns of a matrices take in a part, we will be considering as a what? Double dimensional array. So single dimensional array is what? It contains only rows. Double dimensional arrays contain what? Rows and columns as well. So I think this one is understandable to you. And as of now, I will be teaching you single dimensional array itself. We won't be going deeper into the concepts of a DD array. Lately, whenever we are having time, we will be going with that one as well. Now, single dimensional array is what? It looks like in this structure. We have the subscript, we have the superscript. Consider that it stores in a cell kind of a format. Cell as in like a block of statements in which the values are being stored. So 33 is being stored, 12 is being stored, 32 is being stored. These are my values present inside my cell. Fine, I think I'm clear with this one. And then after it has got locations as in like m of 0, m of 1. We call it as what? Indexing. What do we mean by indexing? Like the positioning of my array elements is to be called as what? Indexing part. So m of 0 is containing the value 33. M of 8 is containing the value 80. M of 4 is containing the value of what? 33. Now you must be having a doubt that the indexing always, I mean, we could have started counting from 1, but remember the concept. Indexing starts its counting from 0. That is what in this format. And if someone wants to store I mean, if you want to find the length counting always starts from 1. So indexing always starts from 0. Counting of a length always starts from 1. These are the differences which we need to understand over on the concepts. So this part is done. That is what a single dimensional array in which how we usually store our data values. When we are done with this one, so from the beginning, what we have just covered up, let's just have a small recapitulation or point of view. First, I've told you what is array and what is the use of array, what are the benefits of using an array. These things have been covered. Then we came up with what? How we usually store our array elements. Array elements are stored using the help of our looping structures. You can use for loop. I'm not going with I assume that you know what are loops, while, do while, and for. But in general, for storing the array elements, we usually use for loops. When we are done with this one, I have told you the dimensional and definitional concept. What do we mean by this one? Dimensional array, the definition of this. Then after I have told you the difference between single dimensional array, double dimensional array. That is what it only represents in rows. It represents in rows and columns as well. Then I have told you the single dimensional array having the elements in this formats, and we are storing in a cell formatted view. Also, it has got indexings, as in like it starts from 0 and ends wherever we want to. And whenever consider that I want to ask, okay, what is the index ninth element? Simply at a result I will be getting as output as what? 11. It's because 11 is being stored as what? My index of my array. So this part is also done. So I'm giving you few minutes of time to take a quick revision, like whatever we have gone through, try to understand like how the indexing goes, the difference between DD and DA arrays, double dimensional and single SD array and DD arrays. Then see the definitional concept, see the uses, the terminologies, and then after, if you're feeling doubts, type it over on the chat box. Then after, we will be coming up with the next part. That is what? The how we usually store the array, the new operator, the length, and all those parts. So as of now, go through it, guys. Anyone having doubts, you can ask me as well. Okay, guys, so I feel like you have covered with the concepts of all those things and no one is having doubts. So probably we can go ahead towards the next part. So next part says to be as what we can store array. I mean, we can store elements over on an array, anything like if it is an integer type, if it is a character type, if it is a float type, or if it is a string type. We can store any kind of a value present, present over there. So all we have to write is what we have to use is what new operator. So with the help of my new operator, I can store any array elements, any data type array elements. So it must be kept in mind that the subscript always begins with the zeroth positions. That is what the indexing, which I've told you earlier before. When a programmer uses array to store the elements, it means that the element of the array are denoted by m of 0 to m of n minus 1. Is because it is being starting from 0. That's why it will be going till the value. Consider that a user has entered the value n. So that's why we have to enter till n minus 1. It's because it starts from 0, not from 1. Now I have told you what is the use of this new operator and how we usually store our values. That thing is completed. Then after using array elements, how we use our array elements for storing any value, subscript, superscript, that thing you can go through it lately. Then after we have the thing that is what integer type. Before covering this integer type, we have the thing that is what an array with empty cell. We consider this one as what cell represents infinite number of cells in the array. Length is used to find the number of elements present in the array in this format. Int m of array equals to 14, 9, 12, 25, 67. Int n equals to m dot length. Output we will be getting as what 5. Why 5? It's because the element starts it counting from 1, 2, 3, 4, 5. I've told you counting in an array like when we use to find our length of an array with the help of what length operator. That is what you can see m dot length. With the help of my length operator, I can find the total number of array elements I have present over there, and I will be using like m of length to get my total number of array elements. That part is done, and I will be having like total 5. It's because it's counting from 1. If it would have been indexing, we would have used like 0, 1, 2 in that format. So that part is something different. I think I am clear with this one, like the finding of length one. And no, I mean the array cells with empty will to be considered as what infinite number of cells. So we don't consider that one. We don't make any cells as an empty part. So now, if someone wants to store integer type of elements over an array, what he has to do, he or she has to do is that int m of array equals to whatever elements you want to store. Just write all those things. Then write a simple code, public class, sample, class name. This is what we are using Java language. If someone wants to use C or C++, you can go ahead. No issues with that one, guys. So int of m equals to 2, 3, 4, 5, 6. These are the elements being stored. And we are running the loop till 5. It's because the element stored is what? 5. And we add that one. So all the elements present over on my array gets summed up. That's what the output I will be getting, as in like the elements inside the array gets as a total summational value. So I think I am clear with this one, in which how we usually take integer type elements in our array. If next question comes to be as in like for character type, if someone wants to store character type of a value, all he or she needs to change is what? Instead of int over there, he will be typing as what? Char C0M computer, whatever elements he wants to store, he will be able to do that one. So that part is clear with that one, guys, in which we can store our values in a character type. We will be using char for storing our values. So C0, not zero, sorry, OMPUTR, whatever I want to store on that concept, I can do that one. I can go ahead with that part. So this part is quite easy over there, in which we are storing our values. So system.out.println, the characters of our elements are what? I'm printing. As their total number of elements is what? 8, we will be getting the value as what? As a printing part in a different lines. But if someone wants to get in same line, he will be removing this ln function. This ln function is just similar like a slash n part. I think you know this quick commands like slash n, slash f for form feed, all those things. So we have learned as of now that how we usually store our array with the help of new operator. Then after, different data types can be stored over there. That is, I mean, like different data types values can be stored over there. Also, we have seen like that m of 0 till m of n minus 1 should be my array elements. It's because we are not being confronted. It's because it starts its value counting from 0. So those things are done. When we are covered with those things, we start with our integer type, how we usually store our values in an integer type. On the right hand side in the notes, we have seen how we usually find the length of our array with our help of a len function. So with the help of len function, I can usually find the number of elements present over on my array. Then we have seen how we usually store a character types of elements. See, character types of elements is just similar like that one, but all we need to use is what? Char, and as we are storing the data elements of character type, we will be storing in single quotes. So this part is done as well. Then we are having the string types, guys. You can easily get that one, that string type will be requiring double quotes for storing the elements and nothing different. Also, we will, instead of the data type char, we will be writing as what? String. So string Amit, Sumit, Rohit. So whatever names you want to store, any sentence kind of a thing, you can do and go ahead with that one as well. Fine. So strings are also done. So I'm giving you a few minutes of time in which you have to revise with the help of the new operator. We usually store our array elements. Then how we usually enter, enter as in like the input for integer type, string type, character type. Then after the use of length operator, and what will gonna happen if we are having this empty cell values. So these things are needed to be understood by you guys. So go through it. Tell me if you're having doubts, and then tell me as in like just type it over the chat box if you're having doubts. Then we will be going ahead with the next concept. Okay, I feel like guys, no one is having doubts on the concept. So we can go up to the next part. So characters are done as well as our strings are as done as well. If someone wants to take as an integer type values, we can go ahead with that one as well. And the compilation and execution is supposed to be as this coding analysis. This is something different over on the concept. For character type, it says to be on this one. Okay, we are just skipping the concept. It's because it's not that much important to require to go through. You can lately pause the videos and you can go through it. But as of now, we will be going to the basic operation of our arrays. So what are those? It says to be as what searching, sorting, insertion, deletion, and merging. These are the important concepts of our array. So we will be going through all of this and we will be I mean, it will be a kind of a explanatory purpose. Just a second, hold on, guys. Okay, guys. We gotta start off with a searching of our array elements. Now, what do we mean by searching? Consider that I mean all of those topics we will be covering like searching, sorting, insertion, deletion, merging. But what do we mean by searching? Consider that we have got thousands of array elements, right? Now I want to find, I give a number lately entered by a user and I want to find whether that element is present over on the array list or not. Okay. So how we gonna do that one? We use the technique to be called as what? Searching. Okay. So there are two types of technique. One is called to be as linear search and another is to be called as what? Binary search technique. So linear search is also to be called as what? Sequential search. This procedure is also called as what? Sequential search algorithm. Now, what do we do in this searching technique is that I consider that I assume that you know what is assignment operator, what is relational operator, what is this relational operator, assignment operator, these things. And we will be using relational operator that is what double equals to over on our linear search algorithm. Then how we gonna do that one? So consider that I have a array elements present like 2000 array elements I have present over on my array. Fine. There are thousands of array elements present over on my array. Then I am going to find that this number entered by the user is present over on that array list or not by using what? By double equals to operator. That is what? My relational operator. So I will be checking with that conditional, I mean that statement, right? Getting the point. So the help of my double equals to, I will be using my array data structure to find the elements over there. So it will be like a beneficial kind of a thing. So we can go ahead with linear structure. This is how a linear structure algorithm works. So with the help of my double equal to, that is what relational operator, I can find number of elements present over on my array. And we can go ahead with that one. So linear structure technique is done. So after that, we have a binary search. Now, Why we are not, I mean, I would personally suggest you to not to go with the linear structure algorithm, linear search algorithm. Why? It's because it is a lengthy process, as in, like, consider that you have 2000 array elements present over there, fine. And if you go searching all of the elements over on 2000 elements, so you have to access every of the elements. So consider my searched element is at the 2000 position, so I have to go from the starting itself and to till the end part, right? So it will be a difficult one to go through it. So it's better to use a binary search algorithm because it is less time consuming as compared to my linear search technique. So when we will be going ahead with our data structure and algorithm, there will be a thing gonna occur named as what, time complexity and space complexity. It is one of the most important concept. Why? It's because whenever we write a code, it should be less time consuming as compared to my other elements. Other elements, as in like other programs. So a program can be done over on different logics, but a program should be self-sufficient enough to be the least time consuming. So linear search, you can understand that one. It will be like a huge lot amount of time consuming over on that part, right? So to get rid of, eventually I will be getting my result. But to get the rid of that part, rid as in like to get not a that amount of time, we will be using what, binary search algorithm. But I would suggest you to go through the linear search, and then we will be starting off with our binary search technique. But it would be better, okay, I'm just completing with the binary search also, then after I will be giving you time for the linear search and binary search as a combination. Now binary search, what it actually does is that it divides my array elements into two halves. Fine, I divide my, consider that I have got 2000 element, I divide my array element into two halves, that is what, 1000 and 1000. Consider that I enter the element which is to be searched. I check with the middle of my array element, is it greater or is it less than that one? So if it is greater, we go to the left right hand side. If it is smaller, we go to the left hand side. But the only deal which we have to know with the part of our binary search is what? The array elements should be arranged in a sorted manner, either in ascending order or descending order. This is the condition we need to know while we are using a binary search technique. It's because we are going to find from the mid of the array elements which is greater and which is smaller. For that reason, it should be in sorted order. See, you can see the array elements is like 17, 31, 49, like a small to increasing format. So that's what we are learning from here as well. Like, we can easily find the elements, that's great, but it should be in smallest order. And how it is less time consuming as compared to my linear search is because we divide the array elements into two halves, and we are dealing with only half part of my array, right? So it generally divides the time complexity and space complexity into half of it. So six elements present over there, we divide into two with three over there. So if it is smaller, we go to the left hand side. If it is larger, we go to the right hand side. So this is how things are being dealt over on our linear search and our binary search. And you can easily estimate that linear search will be taking a lot amount of time as compared to my binary search technique, right? So that's why we usually implement this methodology. So I think you are like most of you are a bit confused of that one. So I'm giving you a few minutes of time, try to understand, analyze the topic, and then after we'll be moving towards our searching based algorithms. So go with the, I mean, sorting based algorithms. So go with the searching based algorithms as of now. Okay, guys. So I guess you have went with the part of this searching based algos in which we have covered the techniques of our linear search as well as our binary search technique. Now our next topic is what? Covering our okay, this is what the major differences lie. Let's just cover this one as well. The differences seems to be as what? Linear search and binary search. The linear search works for both sorted and unsorted data items. As I've told you in the beginning, binary search will be requiring for a sorted algorithm. But I never said that linear search requires this sorted. That means it can either work with my binary sorted algorithm as well as unsorted algorithm. It can work with both of them. Now the search begins at the start of the array, that is from the zeroth position. Always it will be starting from zero, but as we are dividing the array into two halves, we will be starting from either left half or in the right half. So it depends it on the condition whether it is less or greater. It will be going accordingly to that part. Then after we have the sorting technique. Sorting technique is what's the process of arranging the data in specified order, which may be either ascending or descending order. So sorting can be either like selection sort or bubble sort. Now, so these are the two procedures which you will be going through. And when we have learned all these things, I will be explaining you the coding analysis as well. How we usually type in the format of our code. So in selection sort, let's just check this one out. How the procedure goes in our selection sort technique. So we have our array elements like 0, 1, 2, 3, like we have stored in this way. Fine. We have got an indexing in that format. And the elements like 44, 95, 49. So before that sorting, whosoever doesn't know what is sorting, just arranging the elements in certain way. That is what either in ascending or descending order. That is what either in small list, small to bigger. So shall we continue? Continue as in like, can you just be a bit descriptive? Shall we continue? Which part you want to continue, or do you want me to repeat with that concept? You can just type it over on the chat box. Yeah. So what I was saying as in like, so selection sort is what? It's a procedure of what? Arranging the elements in either ascending or descending order. And how it works, consider that it goes to the zeroth element, and it checks with the next most element, like it checks with the next elements, which is the smallest one. So 44 checks with the 97. Is it smaller as compared to 44? No. It goes to 49. No, it is also bigger as compared to 44. Then it checks with 56, 89. Then 27. 27 is smaller, but it checks with the least most element over on my array. The least most element is what? 15. It gets interchanged with my 15th one. So 15 comes in the position of my 0th, and 44 comes in the position of my 6th. And then again, when it is being stored as in like 15th way, I will be checking with this one. That is what 97 gets checked with what? My the least most as compared to all of this. So the least most is what? 27. 27 gets interchanged with my first index with my fifth one. Now 97 is being stored over on my fifth element, and 27 is being stored over on my first element. First element is what? First indexed element. And henceforth, the procedure goes on, and we get in what? Ascending ordered elements. This is how we usually go in a formatted view of our ascending order to find that concept as a whole. So, I mean, selection sort is a procedure in which we can go a technique. In this way, selection sort goes with this procedure technique. So when we are done with this one, we have our next concept says to be as what? So selection sort is done. Now this one is also having its time complexity and space complexity. As compared to our towards our bubble sort, selection sort will be taking a bit more time as compared towards our bubble sort. So the complexity of my selection sort will be bigger as compared to my bubble sort technique. This is how things go on over on the purpose. So my this is what my selection sort technique. But as I mentioned you, as compared to my bubble sort, it will be like more time consuming as compared to my like bubble sort. So as of now, go through the procedure of your selection sort technique. Tell me if you're having doubts. Try to understand how the procedure works in. Then after a few minutes, we will be starting off with our bubble sort algorithm. So go through it, guys. Okay, guys. So I guess you have went with the part of for the selection sort technique, right? Next, we have our what is the bubble sort technique, right? In a bubble sort technique, what we actually do is that let me just explain you the procedure. But before that, I've made you understand it is less time consuming and it is like less space consuming as compared to my selection sort technique. Why? It's because the procedure is like it compares the first element to its next element. Excuse me, guys. If it finds to be as small as compared to its the next most element, it changes or else it goes to its next part. So 9 is smaller than 6. Yes, it interchanges to 6 and 9 goes to this one. Then 9 compares to 24. Is 9 smaller than 24? No, it remains same. 24 compares with 3. 24 gets interchanged with the 3 and gets to the shifted to this position. This is how 24 goes to the end part. I mean, not end part. This 45 goes to the end part in this way. Then again, the search begins from the 6 to 9. 6 to 9 gets compared and it gets shifted over on this part. And this is how get 3 gets converted at the beginning and it goes to the left hand side. That is what the 45 goes to the end part. But the major differences arises in the binary search bubble sort is that we check with the next most element. But in our binary search, selection sort technique, we check with our complete set of data values. That is what which is smaller as compared to all. So the major differences allows as in like it goes to the next part, it goes to the all of the elements. It accesses all of the elements of it. So I think I've clarified your doubt with the bubble sort and selection sort algorithm. Those things are cleared. Then lastly, we have the topic of DD arrays, double dimensional arrays. It contains what my rows and columns as a whole sum. That is what it starts from 0 0. So what is my 0 0th position? 22. 0 1 position is what? 44. So which contains what my rows and columns is to be called as DD arrays. This is what double dimensional array actually means like. Now we will be starting with the coding analysis of a linear search. Before that, I'm giving you certain time to go with the bubble sort technique, and then after we will be starting with the coding analysis purpose. So go through it, guys. Alright guys, so we have covered up with the revisional concepts as well. Now our next motto is to what? Go with the coding concept, starting with our what linear search algorithm, right? So this is what we will be going with the Java language. As mentioned earlier before, if someone wants to go with different coding language, you can go ahead with that one. That's great. But we will be going as of now with the Java language. First, we take input to the user command by input stream reader class, buffer reader class. We take the array elements over there. After storing the array elements, we use this relational operator, which I've told you earlier before. Double equals to will be used for checking what my element is present over the array or not. So double equals to will be what my checking statement to go through it whether it is present or not. So first I write an array for getting the access of my index elements. Then after what I do is that m of I is equals to what sh. That is what the elements needed to be searched. Right. M of I is double equals to what sh. That is what the element I need to search over on the concept. If it is true, we use a flag variable and we print that the element is found. Else, what we do is that we say that element is not found over on the concept. So this is how we generally go through it, as in like the linear search algorithm technique, in which we use our relational operator to check whether the element is present or not. First, we get access of all the elements, then we relate that thing. This is how we have done that one. Then after we use the binary search technique, as said, binary search technique takes less time as compared to my linear search algorithm. So this part is what my binary search algorithm find. What I'm doing is that this part is the array, I mean elements including part, and this is what the number which is to be searched. We enter that number. This is the procedure. For here, we are using, I mean, scanner class. I mean, sorry, not scanner class, input stream reader class. For that, for next purpose, we will be using what our input stream reader class. We have the thing called P equals to LB plus UB divided 2. UB we consider as what upper bound. Excuse me, guys. LB we consider as what lower bound. We divide the array into two halves, and m of p is what less than number to be searched. That is what ns. Fine. P equals to what ub plus lb divided 2, and m of p is what less than number to be searched. If it is true, we go to the right hand side. If it is less, we go to the left hand side. And then the same implementation of a linear search algorithm is being applied. So what I'm doing is that I'm repeating the concept with you guys. So we divide the array into two halves, that which contains my P. After dividing that one, we check that if it is greater, we go to the right hand side. If it is, I mean, for the mid element, to the number which is to be searched. If it is smaller, we go to the left hand side. So this is what my procedure is included over on my linear search. I mean, sorry, binary search algorithm. Division of my array, then going to the left and right hand side. Then after implementing the same logic, which is being a part of my linear search algorithm. So our two major searching techniques, that is what linear search and binary search technique is done. So go through it, try to implement over on some editor. Then after I will be explaining you the sorting algorithms. Guys, so as we have covered up with our sorting techniques, sorry, searching techniques, we will be going up forward with our sorting algorithms. I've explained you sorting algorithm is just like arranging the elements in desired order, either in ascending or descending order. So the techniques include insertion sort, merge sort, quick sort, bubble sort, and selection sort, and we will be implementing two of them as of now. So I have explained you how the procedure works in a one selection sort technique. Now this is the way we write. So first we write the code of what looping structure, which is like I equals to 0, I less than 9, I plus plus. We consider the first element as the smallest one, and then we increased it to the next one, and then we check with the first element with the next most element. If it is finding to be the smallest, we interchange. That is what we swap our elements. Most of you know, I mean, everyone knows the how stack swapping works, right? So swapping procedure takes place. After we are done with that one, we print our sorted elements with the help of our arrays. So first I'm explaining you, repeating the step. We use the input structure, that is what input stream reader class. If I want to use scanner class, I can do that one as well. It's up to me, input stream class or either scanner class. Then after we create an array, after creating the array, we use a loop for storing the array elements. Then we store the first element as the smallest, and we use a second loop that is called to be called as J loop structure. We print that one to get our output. That is what m of j is less than m of min. If it is finding to be that concept, we use the swapping part, or else we swapping is not done. So similarly, we can. So that was what with the help of our numbers, right? If someone wants to play with the string type, he can do that one as well, like Delhi, Agra in this way. So the first most element like A, B, C, in this way, the elements will be sorted. That is what using the help of our alphabetical order. So that part is easy. Now we will be going with the bubble sort technique. Bubble sort technique is that we usually use that is what I equals to 0, I less than 9, I plus plus. That's fine. Then after we run J loop, J loop is being run with what for the next, it stores my next most element. So the first element gets compared with the second element. If it is finding to be the less, it doesn't swaps. If it is finds to be as what less, it will swap that one. So this is how technique works in. So I will be comparing my I loop with the J loop. That is what first element with the second most element. If it is finding to be the smaller, we swap that value. Fine. Then after, this is what my swapping procedure, or it is like t equals to m of j equals to m of j plus 1, m of j plus 1 equals to t. So this is how our bubble sort technique basically works. It compares with the next most element, and selection sort goes with the smallest element present over on my array list. Fine. But if someone asks you that what is the merge sort technique actually means, it actually does as in like combines the array into two and forms it to be as I mean not combines, it divides the array into two halves. It is to be called as what divide and conquer. So after dividing the array, it swaps which is the smallest, and then it compares with the value. So similarly, if someone asks you that, can you give me an example of a sorting algorithm which follows a divide and conquer rule? You will be telling as merge sort. If someone asks you that, can you give me an example of a searching algorithm which follows what? Divide and conquer, you will be telling as in like a binary search algo follows that methodology. So you have to go with the concepts of that one and just revise the topics, and then after we will be having a quick recapitulation over on the part. So go ahead guys. Okay, guys. So what we will be doing, as in like a small, quick revision. So what we have learned from our starting purpose, we have came up with our arrays. Arrays is what it's a part of a data structures and algorithm. I have told you what does this array actually means. Then it comes to be as what how we usually store our array elements with the help of a looping structure. Then we have came up like the definitional structure of a dimensional array. I've told you the divisional concept, that is what a single dimensional array and double dimensional array. Single dimensional array stores only rows, double dimensional array stores rows and columns as well. We have got a cells in which we store our array elements. We are having indexing formats in which the array elements are being stored with the help of positioning. Then how we usually store our array elements with the help of a new operator. Like if I want to store array elements in integer, float, character, strings, I have given you example how we usually store in that format. Then we came up with a thing like how we usually find our length of an array with the help of a length function. Then if someone makes the thing as in what empty cell format, so it will be like an infinite number of cell we consider as what. This is what the example for the integer type I've explained you. This is for the example of my carrier type. I explained you this one as well. And lastly, we had this what a string type. Excuse me, guys. When we had covered all these things, we came up with the properties of an array, which seems to be as in what the searching, sorting, merging, insertion, and deletion. So searching as in like searching forms to be as what two types of a searching: linear search algo, binary search algo. Fine. When we are done with this one, we came up with the procedure and technique of my linear search, how it works, and the procedure and technique of our binary search. I have told you, I have explained you these two concepts. Then I have told like which is having best time complexity and best space complexity. I told you that the binary search is having this time complexity is very less as compared to my linear search algorithm. Add, but the major differences allows as in like it should be in sorted format. Also, the binary search starts is searching from its mid part, that either left hand side, either right hand side. But in a linear search, it starts searching from our first, that is what zeroth element. When we are done with this thing, we have seen the differences. Then after we came up with the sorting algo. Sorting algo is like arranging the elements either in ascending order or in descending order. I've explained you how the procedure works in selection sort and bubble sort. That selection sort goes to the I mean the smallest element present over on the array and it interchanges. That is what swaps its position. But the bubble sort goes to the next most element, which is the smallest, and it just interchanges position. And I've also told as well which is what having the best time complexity and space complexity. After we completed that one, I have told you what does this multi-dimensional array actually means, like double dimensional array which contains rows and columns as well. When we had covered this one, we came up with the coding analysis, that linear search works on this relational operators, that is what double equals to, but binary search works on the condition like dividing the array, going to the left hand side, going to the right hand side, then after using the relational operator. I've explained you that concept. Then I have explained you the searching algo as well as searching algo, not sorry, sorting algorithm, that is what binary search, and what is the next thing, that is what a bubble sort. I've explained you which is to be called as what divide and conquer rule. Our binary search algorithm is to be called as for searching examples is what binary search example is to be called as what divide and conquer, and our bubble sort is merge sort is to be considered as what divide and conquer. So these topics were covered in a wholesome as a together in our array. I feel like no one is having doubts, or else you can type it over on the comment box. I will be helping you out. So our main major motto of our arrays are done today. Probably on our next streaming, we will be doing as in what the linked list type. After that, we will be going with our trees. But remember the concept, there's a difference between linear data structure and non-linear data structure. Just as of now, understand this thing. The arrays are to be called as a linear data structure of mine. So it is a part of my linear data structure. So I feel like is no one is having doubts. So what we can do is that we can wrap the session off over here, and probably we can meet over on our next stream. So thank you guys.